NCM Learning Center. Good morning, friends. NCM Learning Center has been conducting YouTube classes for GATE, IES, ISRO, TNEB, RRB, and other government examinations. As per plan of August to September plan, we have to take classes digital learning for this week. So we will discuss basic flip-flop concepts. We may expect the basics of flip-flop concepts in the TNEB and TRB one more questions. But we cannot expect the question in the GATE, IES, ISR questions because it is a very basic one. But by the basic only you can solve the sequence circuit questions as well as the counter questions. So we may expect the sequence circuit problem and counter problem. To solve that problem, the flip-flop basic is must required. So we will discuss the basics of flip-flops. First, you should know the difference between the combinatorial circuit and sequence circuits. Here, the sequential circuits, it will store a single bit data. The logic devices does not store the any data. So flip-flop is a memory device, but logic device is a memory-less device. Another one point, in a sequence circuit, there is a feedback because output is taken as an input. In the logic devices, there is no feedback. Fourth one comparison, in the sequence circuit, the output is depends on both input and output. But the logic device, the output is depend only the present input. That is the difference. The types of flip-flops are SR flip-flop, JK flip-flop, D flip-flop, T flip-flop. Like a combinatorial circuits, you should know this equation and truth table. For example, in the combinatorial circuits, for AND gate, you should know the equation. AND gate equation Y is equal to A dot B. You should know the truth table. Similarly, you should remember this characteristic equation formula. So, for the SR flip-flop, this is a symbol S or is a clock. The another one device is in the sequence device, the clock is required. If you apply the clock, then only the state will be changed. If it does not apply the clock, the output will not get. So, but in the logic device, no need of clock. Characteristic equation Q plus is equal to S plus R for Q. Q means just last output. That means present state. Q plus means present output. That means next state. Just the previous output is Q. Just now output is the Q plus. For the JK flip-flop, is a symbol JK. The equation is XOR gate. Like as XOR gate, Q plus is equal to J Q bar plus K bar Q. What will be the XOR gate output? Y is equal to A B bar plus A bar B. Similarly, here Q plus is equal to J Q bar plus K bar Q. You should know this formula at any time. For the T flip-flop, same that of JK flip-flop. Here, instead of J and K for a different input, a single input is given T. So, we will get this equation Q plus is equal to T Q for plus D for Q. XOR gate. Then finally D flip-flop. D flip-flop output is Q plus is equal to T. For the four equation you should know at any time. Now we will discuss the truth table. We know the characteristic Q plus is equal to S plus R for Q. In the SR flip-flop is a set reset flip-flop. Set and reset both are 0. Then the output Q plus will be the present state. What is the present state? That will be the output. If the present state is 0, the output will be a 0. If the present state is 1, the output will be 1 when the clock is applied. If set is applied, the output will be always 1. It does not depend on the present state. If the reset is 1, output always 0. Reset means 0, so output always 0. If set and reset both are high, it's undefined. We cannot give both set and reset as a high. Okay, so this is the truth table. The truth table of J K flip-flop, the characterization should know Q plus is equal to J Q plus K for Q. This value, without substituting S or Q in this equation, you should tell. In the J K flip-flop, just a modified form of SR flip-flop. Okay, same SR flip-flop, but here when both set and resets are 1, it's modified to get complement of present state. In the JK flip-flop, when set and reset J and Q are 0, the output is just a present set. If the present set is 1, the next set will be 1. If the present set is 0, the next set will be 0. For when set and reset J and Q are both are 0. When J are 1, set is 1, output is always 1. If reset K is 1, output always 0. If set and reset both are high, output will be complement of the present state. For example, if the present state is 0, the output will be 1. If the present state is 1, the output will be 0. Okay, that's modified form of SR flip-flop. Then T flip-flop. The D flip-flop just XOR gate. For the XOR gate, if the both input is different, then output will be 1 high. Otherwise, the output will be 0. Similarly here, if both are same, the output will be 0. Both are different, the output will be 1. For the D flip-flop, the output will be D. Does not depends on present state. If D is equal to 0, output will be 0. If D is high, output always high. Okay. If you have any doubts in this video, just post your doubts or NCM Learning WhatsApp group. Good. Thank you. Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.